Hi everyone. In this video we're going to talk about rational functions, which are closely related to functions that we've already talked about, which are polynomial functions. So the way I want to start here is I want to give us two polynomials. The first one, f of x, is going to be x squared plus 1, and my second polynomial is going to be g of x, and it's going to be 2x plus 3. Okay. So I have two polynomials here, and if I want to combine them, there's a couple things that I could do. I could take my function f and I could add it to my function g. So I could add these two together. So I'd get x squared plus 1 plus 2x plus 3, which is x squared plus 2x plus 4. Okay, so if I added these two polynomials together, it turns out that I get another polynomial function. So I didn't get anything new. So what else I could do is I could subtract them. So I could do f minus g. And if I did that, the end result would be x squared minus 2x. And I would have this positive 1 here minus 3. Becomes minus 2. And so I'd have this. So if I subtracted my functions, you can see here that I still have a polynomial. So I could multiply them together. I could look at f times g, x squared plus 1 times 2x plus 3. Okay. And so in order to do this, we'd have to FOIL this out, right? So we would get 2x cubed. So if I multiply the first two terms, right, so 2x cubed. Then if I think ahead here, so if I multiply this 3 times x squared, I'm going to get my x squared term here. So I would get plus 3x squared. Then if I have the last two, I would do plus 2x and then plus 3. Okay, so I can see if I multiplied them, I also get a polynomial. And if we think of our four operations here, the last thing that I would do is I could divide them. Right? So I could do f divided by g, and let's see what happens. We would get x squared plus 1 divided by 2x plus 3. All right, so in this last case right here, so in the last case, f divided by g, it seems like I get something new. So if I added these two functions together, I get a polynomial. If I subtract them, I get a polynomial. If I multiply them, I get a polynomial. But if I divide them, I get something that is new. Okay, and this new thing is what we call a rational function. Okay, so this right here is a rational function. Okay. So when we take two polynomials and we divide them, the end result is a new type of function that we call a rational function. Okay, so what I'm going to do is I'm going to pause here for a second, and I'm going to bring up a new definition for us. All right, so we are back, and I have a definition written up here. This is a little bit more formal. So we would say that we have a function r of x. It's a rational function if you can write it in the form p of x divided by q of x, where p and q are polynomial functions. So one of the things that we have to look out for is functions that may not always look like rational functions on the surface. So take, for example, this function right here. Let's say r of x is equal to 1 over x plus 1 over x plus 1. Okay. Now if I look at this function, it doesn't look like my definition. So in a rational function, for the definition, I should have one single fraction, where the numerator is a polynomial and the denominator is a polynomial, but I don't. I have two fractions here. I have this fraction and this fraction. So if I wanted to see this as a rational function based on my previous definition, what I would have to do is get some common denominators. Now, we might be familiar with doing this with fractions, but now what we're going to have is more algebraic expressions. So in my experience, the easiest way to get a common denominator with expressions like this is not to try and look for the least common denominator, just look for any common denominator. Now, when I'm doing that, all I'm going to do is take every denominator that I have and I'm going to multiply them together. Right, so we'll do this with 2 here. And I want to write this as something that has a denominator x times x plus 1. Right, so I have 2 denominators here, an x and an x plus 1, so I'm going to multiply them together. Well, if I want to turn these into something that has that denominator, what I'll do is I'll multiply the top and bottom of both fractions. So my fraction 1 over x plus 1, what I'm going to do is I know that I need to add another x down here, x plus 1 times x. So I'm going to multiply this by something that has an x in the denominator. And if I don't want to change anything, then I need to also multiply by an x in the numerator. Okay. So a similar idea for my first fraction, 1 over x. I want there to be another term down here. I want there to be another x plus 1, so x times x plus 1. So what I have to do is multiply the numerator and denominator by x plus 1. Okay. So let's think about this. What do I get? What do I get? So this is equal to x plus 1 divided by x times x plus 1 plus x divided by x times x plus 1. And so if I bring those two together. So what I've done is I've now created 2 fractions that have a common denominator. That denominator is x times x plus 1. And so now what I can do is just add these 2 fractions together. So in order to do that, I'm going to have the same denominator, which is already written over here. And if I add these together, I get x plus 1 plus x, which is going to give me a final result of 2x plus 1. Okay, so this is a rational function. Even though it didn't look like it on the surface, with some common denominators and just rewriting it in a different way, we can see that it does fit our form for a rational function. Right, so I'm going to clean this up, and I'll be back with one more example. All right, so here's another function. We see it's p of x, and it's equal to 3/2 minus x divided by x squared plus 5. So the question I ask myself is this a rational function? So very much similar to what we did before. I see that I have 2 fractions, and I want to make them into 1 fraction. Okay. So here's how I'm going to do that. I'm going to get them with the same denominator, and I'm just going to take the product of all the denominators to do that. Okay. So my end result should look something like this. I should have something with a denominator of 2 times x squared plus 5. Now I don't know what the numerator is, but we're going to figure that out. So I took this 2, I multiplied by this x squared plus 5, and that's going to be my new denominator. All right. So let's start with this one. X divided by x squared plus 5. I have the x squared plus 5 part that I was looking for, but what I need is another 2. Right, so what I'm going to do is multiply my numerator and denominator by 2. So I'm not going to change anything, but I'll have the right denominator. And for this one, what am I going to multiply by? Well, I have the 2, but I don't have the x squared plus 5. Okay, so I'm going to have to multiply on top and bottom by this x squared plus 5. Okay, so let's put this in parentheses just so we remember. All right, so our intermediate step, let's clean all this up. My first fraction right here, so what I'm going to do, I get 3 times x squared plus 5, so that's 3x squared plus 15, all divided by 2 times x squared plus 5, minus, right, minus over here, so I get just 2x in the numerator and a 2 times x squared plus 5 in the denominator. Okay, so if I'm going to put all these together, looks like my denominators are the same, so I just need to subtract my numerators, and I get 3x squared minus 2x plus 15. Okay, so we can see that what I had before were two different fractions, 3/2 minus x over x squared plus 5, but with a little bit of rearranging, we can get this down to a form where we have a polynomial divided by a polynomial, and so this is in fact a rational function. So in the coming videos, what we're going to do is we're going to look at all sorts of different properties of rational functions. We're going to see how do we find their zeros and what other sort of interesting properties do they have, and we'll see if we can figure them out. All right, so I'll see you then.